The importance of design patterns in software development. Introduction. In software development, creating code that is both efficient and maintainable is crucial. However, as projects grow in complexity, it can become challenging to maintain consistency and avoid common coding mistakes. This is where design patterns come in. Design patterns are reusable solutions to common coding problems. They help you standardize your coding approach and make your code more efficient, maintainable, and scalable. By using design patterns, you can write better code faster and reduce the risk of introducing bugs or other errors. This video will explore the importance of design patterns in software development, including their benefits, types, and best practices for implementing them effectively. The importance of design patterns in software development. Design patterns are essential in software development for several reasons, including 1. Improving code quality and maintainability. Design patterns help ensure that your code follows best practices and is consistent across your project. By following a standard set of patterns, you can reduce the risk of introducing bugs and other errors in your code. Moreover, using design patterns can make your code more maintainable. As your codebase grows, it can become challenging to keep track of all the code, making it harder to modify and update. By using design patterns, you can structure your code in a way that is easy to modify and extend, reducing the risk of introducing new bugs or errors. 2. Promoting reusability. Design patterns encourage reusability, which can save you time and effort in the long run. By creating reusable code, you can reduce the amount of code you need to write and test, speeding up the development process. Moreover, by using design patterns, you can make your code more modular. This means that you can easily swap out components or update them without affecting the rest of your codebase. As a result, you can reduce the risk of introducing new bugs or errors when updating your code. 3. Encouraging best practices. Design patterns help you follow best practices in software development. By using well-established patterns, you can ensure that your code is efficient, maintainable, and scalable. This can help you avoid common coding mistakes and improve the quality of your code. 4. Streamlining the development process. By using design patterns, you can streamline the development process. Design patterns provide a standard set of solutions to common coding problems, which can save you time and effort in the long run. Moreover, by creating reusable code, you can speed up the development process and reduce the amount of code you need to write and test. 5. Enhancing code readability. Design patterns can make your code more readable and easier to understand. By following a standard set of patterns, you can make your code more consistent and easier to read, reducing the risk of introducing new bugs or errors. Moreover, by creating modular code, you can make it easier to understand and modify, making it more accessible to other developers. Types of design patterns. There are 3 main types of design patterns: creational, structural, and behavioral. 1. Creational design patterns. Creational design patterns help you create objects in a way that is efficient and maintainable. They provide solutions to common object creation problems, such as how to create objects without exposing the creation logic, how to create objects that are configurable, and how to create objects that are easy to test. Examples of creational design patterns include singleton, factory, abstract factory, builder, and prototype. Singleton is a creational design pattern that ensures that a class has only one instance, and provides a global point of access to it. This can be useful for creating objects that are shared across the entire application, such as database connections or logging systems. Factory is another creational design pattern that provides a way to create objects without exposing the creation logic. This can be useful for creating objects that require complex initialization or configuration, such as UI controls or network connections. Abstract factory is a variation of the factory pattern that provides a way to create families of related objects, such as UI controls for different operating systems or database drivers for different platforms. Builder is a creational pattern that provides a way to construct complex objects step by step. This can be useful for creating objects that have many different configuration options or properties. Prototype is a creational pattern that provides a way to create new objects by cloning existing ones. This can be useful for creating objects that are expensive to create or require complex initialization. 2. Structural design patterns. Structural design patterns help you organize your code in a way that is efficient and maintainable. They provide solutions to common organizational problems, such as how to structure your code in a way that is easy to modify and extend, how to create flexible and reusable code, and how to reduce coupling between different parts of your code. Examples of structural design patterns include adapter, bridge, composite, decorator, facade, flyweight, and proxy. Adapter is a structural pattern that provides a way to convert the interface of one class into another interface that clients expect. This can be useful for integrating existing code or libraries into your application. Bridge is another structural pattern that provides a way to separate the implementation of an object from its interface. This can be useful for creating flexible and reusable code that can be easily modified and extended. Composite is a structural pattern that provides a way to create tree-like structures of objects, where individual objects and groups of objects can be treated in the same way. This can be useful for creating complex hierarchical structures, such as user interfaces or file systems. Decorator is a structural pattern that provides a way to add behavior or functionality to individual objects without changing their class. This can be useful for adding new features to existing objects, such as adding new formatting options to a text editor. Facade is a structural pattern that provides a simplified interface to a complex system of classes. This can be useful for hiding the complexity of a system from clients and providing a more straightforward interface for common tasks. Flyweight is a structural pattern that provides a way to share objects that have similar properties to reduce memory usage. This can be useful for creating objects that are used frequently but have a large memory footprint, such as graphical elements in a game or user interface. Proxy is a structural pattern that provides a way to control access to an object. This can be useful for creating objects that are expensive to create or require complex initialization, or for providing security or access control to sensitive data. 3. Behavioral design patterns. Behavioral design patterns help you manage the behavior and communication between objects in your code. They provide solutions to common problems, such as how to manage the flow of control between different objects, how to manage communication between objects, and how to implement algorithms and processes. Examples of behavioral design patterns include chain of responsibility, command, interpreter, iterator, mediator, memento, observer, state, strategy, template method, and visitor. Chain of responsibility is a behavioral pattern that provides a way to handle requests in a chain of objects, where each object can handle the request or pass it on to the next object in the chain. This can be useful for creating flexible and extensible code that can handle requests in a variety of ways. Command is another behavioral pattern that provides a way to encapsulate a request as an object, which can be stored and executed at a later time. This can be useful for creating undo and redo functionality, or for implementing multi-step processes. Interpreter is a behavioral pattern that provides a way to define a grammar or language for a system, and to interpret expressions in that language. This can be useful for creating domain-specific languages, or for implementing rules-based systems. Iterator is a behavioral pattern that provides a way to traverse a collection of objects without exposing the underlying implementation. This can be useful for creating reusable code that can work with different types of collections. Mediator is a behavioral pattern that provides a way to centralize the communication between objects and to decouple the objects from each other. This can be useful for creating complex systems where individual objects need to communicate with each other in a flexible and extensible way. Memento is a behavioral pattern that provides a way to save and restore the state of an object without exposing its implementation details. This can be useful for creating undo and redo functionality or for implementing snapshot functionality. Observer is a behavioral pattern that provides a way to notify objects when the state of another object changes. This can be useful for creating loosely coupled systems where different objects need to react to changes in the system. State is a behavioral pattern that provides a way to encapsulate the state of an object and to provide different behavior based on that state. This can be useful for creating objects that need to change their behavior based on different conditions, such as a traffic light that changes its behavior based on the state of the intersection. Strategy is a behavioral pattern that provides a way to encapsulate different algorithms or strategies for solving a problem and to switch between them at runtime. This can be useful for creating flexible and extensible code that can adapt to different situations. Template method is a behavioral pattern that provides a way to define a skeleton for an algorithm and to allow subclasses to implement certain steps of the algorithm. This can be useful for creating reusable code that can work with different types of objects. Visitor is a behavioral pattern that provides a way to separate the algorithm for traversing an object structure from the objects themselves. This can be useful for creating complex algorithms that need to work with different types of objects. Conclusion. In conclusion, design patterns are an essential part of software development. They provide a way to solve common problems in a way that is reusable, maintainable, and extensible. By understanding the different types of design patterns and when to use them, you can create more robust and flexible software systems. Whether you are a seasoned developer or just starting out, it is essential to understand the importance of design patterns in software development. They can help you create more efficient, maintainable, and flexible code, and can save you time and effort in the long run. So take the time to learn about design patterns and start using them in your own projects today.